All the sorting algorithms we studied so far have been comparison sorts that required that the array elements be of a type that implemented comparable. Next, we discuss why the efficient comparison sorts are optimal and then examine one non-comparison sort. We conclude by running a GUI implementation that includes all the sorts. We begin by examining what it means for an algorithm to be optimal. We say that an algorithm is optimal when it can be proven that no more efficient solutions can exist, establishing a lower bound. Although the details are beyond our discussion here, it can be proven that n log n is a lower bound for comparison sorting. Consequently, the heap, merge, and quick sorts are all optimal comparison sorts. There are other ways to perform a sort. It's possible to sort without doing comparisons. The radix sort is an example of one such sort. Let's consider how the radix sort differs from those we have studied so far. A radix sort requires a key that can be considered to be a number in some base or radix. There are two types of radix sorts. The first is a least significant digit radix sort. It is modeled after a punched card sorter that was used in the early days of data processing. Cards would be run through the sorter, sorting one column of the card that defined the key at a time, starting with the least significant digit. The other type, characterized as a most significant digit radix sort, is a recursive divide and conquer sort. In both cases, the efficiency is the same, O of kn, where k is the number of digits in the key. If k is much smaller than n, which would generally be true, this is a linear sort. We conclude our discussion of sorting by examining an example that includes all 7 sorts. The sort interface defines the comparison sorts. All 6 comparison sorts implement that interface. The radix sort does not. The GUI class sortGUI allows us to select which of the 7 sorts to run. So let's now run one of those sorts. And perhaps we'll pick one of the more efficient ones, but first let me put in some values. So this is set up so that it sorts an array of integers. And the one that I'll pick is, I said I would pick an efficient sort, so let's do the quick sort. And what we notice is that all of the values come out in sorted order. So you can take a look at the other sorts and try some of them and see that they all indeed produce a correct sorted array.